Okay, so when you multiply A inverse times A, it just gives you the identity matrix, and the identity matrix times X really is just the matrix X, okay, because 1 times X is just going to equal X, okay, and then here, you don't, I mean, that's just what you end up doing, okay, so this is the work behind it. You're not going to show that much work when you actually do the problem. You're just going to do this to get your answer every single time, but this is kind of the proof of why it works, basically. Okay? If you want to solve for matrix X, all you have to do is multiply both sides by A inverse, but you really are not going to multiply A inverse by A because you know in your head that's just going to cancel everything out and get X by itself. So the only multiplication you'll need to do is take A inverse times B, and it'll give you your answer. And Kyle was saying, do you want us to write our answer like this? Or do you want to write it as an ordered pair? And I'm fine with whatever. It doesn't matter. If you want to write xy equals the answer, or just write the ordered pair and circle it, it makes no difference to me. So going back to the actual problem, what you'll do to solve this is you'll enter this as your matrix A. You'll enter this matrix as your matrix B, and all I would do on my calculator is take A inverse, you know you have the inverse button on your calculator, I'll take the inverse of a matrix, A inverse times matrix B, and whatever you get for an answer, that is your X and Y value where those two lines would have intersected. It's kind of a fast way to find the solution. I don't know if it's necessarily faster than substitution or elimination, but it's a fairly fast way to find out where those two lines would meet. And what was the answer?
2 negative
2, negative 3. Okay, so like this, or like this.
Yeah.
Questions?
Why do you write it like that? The 2, negative 3, and the circle thing.
Over here as a coordinate?
Oh,
Because when
yeah,
it's a system of equations. So I mean, what I'm
that's
looking
the
for,
coordinate where it.
that's the coordinate where the two lines meet. Okay? Other questions? Good question. Good question. Other questions? Emma?
For the X and Y, how do you know that X is on top and Y is on bottom?
It has to be in order for it to match the equation right here. When you multiply matrices, you know how you go across the rows and down the columns? It'd be 3 times X plus negative 5 times Y, and that matches what the original equation was. Okay? Yeah, so, I mean, if they would ever mess with you here and put the Y first and then the X, you might want to write them back in the correct order. Put your X first, then your Y, so that way you can make that.
That's one reason why I like thinking of everything as plus negatives or 1 over if you're whatever it is, because then it's easier to move things around.
Mm-hmm. Sure. Yep. No, that makes sense. All right? So, now like I said, for a simple equation like this, here's what you'll be expected to do, I guess, on your test. We'll give you this, the system of equations algebraically. We will ask you to write the matrix equation, and then we'll ask you for the answer. Okay? We'll ask you for the answer. If you want to show a bunch of steps, show a bunch of steps. Okay? But as long as you write the matrix equation and can get the correct answer for the coordinate where the lines meet, you're good. You're going to use your calculator for this.
Are we,
Okay?
never mind. It was,
Right. Did everybody get the right answer?
Yeah.
Yeah.
No, I think,
I definitely got the right answer.
Everybody good on their calculators? Okay? Alright. Now, like I said, I probably wouldn't have used a calculator and a matrix equation to solve that if somebody would give that problem to me. Okay? I probably would have used elimination because that's fresh in my head and I do it with all the algebra kids. Okay? Or substitution. Alright? But, somebody gives you something like this. If somebody would give you something like this, I purposely didn't put a y in there to make sure you fill that in with a 0. If somebody would give me an equation like this, and I have these these answers are not gonna be nice, I'm almost guaranteed, because I just made this problem up,
So
okay?
you're actually doing that?
Okay, we're gonna do it,
Oh,
yeah,
okay.
yeah, we're gonna do it.
So
But if somebody give me a problem like this, I would not do this algebraically, okay? You could get this z by itself, and then substitute it into these other two
And then get
equations,
another
and then
one
do it
back.
again, and do it, you do substitution a few times, and you could eventually solve it algebraically,
So-
working it out.
So would it basically turn into 3, 1 for the top row, then
It's gonna be a, what size?
3 by 3,
3 by 3.
and then it would be and then -1, 2, 3, 4, 0, 7, and then x, y, z equals 8, -5, and 12.
So you have to have the same number of variables for the number of equations that you have?
Because otherwise there wouldn't be enough information to necessarily solve it.
Okay.
Because geometrically, what this is a plane. It's a flat surface that goes on forever. Okay? And if all I have is two planes, all I have is two planes, there'd be no way to figure out one solution, because if two planes intersect, they do so at an infinite number of coordinates on a line. So there would not be just one coordinate where those two planes intersect. So you gotta have three planes and to be able to find one coordinate of intersection, or one point that would satisfy all three. Now, I don't even know if this one has a solution. I hope it does.
I got 3.37.
So it is working out, Zach?
I
I did, just so you know that if you don't see that variable, make sure you put a 0 in there. Yep. So I purposely left y out of that last one, because that could happen.
Alright.
So just put a 0 in, because it's like you have 4x plus 0y plus 7z. Okay? But yeah, if there are three variables, you'll definitely have three equations in order to be able to solve it. Okay? And will it change it to fractions?
I didn't try it.
Yeah, I did.
It did? Okay.
Yeah.
So we're still taking that first matrix times the third one? The inverse?
The inverse of this one
Yeah.
times b. Yep. Kyle, what is the answer in fraction form?
Let us know, Kyle.
What? In fraction form?
Yeah, I had 3
3.38.
and then
14
I have
or
4.
37.
I thought you said you got
I
it.
did
378,
125
378.
over 37.
Kyle, go ahead.
Yeah.
Too many voices.
I got
125.
He's got it.
125 over 37.
125.
Yeah. Negative 18 over 37. And negative 8 over 37.
Anybody else? You didn't have that? Anybody else have that?
I did. I had that.
Yeah, that's what I got.
Okay.
You got it right. Did you?
Remember, your calculator will change everything to fractions for you. You just have to hit the math button, change to fraction.
Why
Okay.
is it that they're all over 37?
Because so it should like the determinant's 37.
Probably because the determinant of this matrix was 37. And so then when you did the inverse of this matrix, you know how the inverse has 1 over the determinant times. So I'm betting that's why.
So, is it common for the denominators to be the same?
I suppose if all of these are integers here,
Okay, that makes sense.
I mean, because a lot of times, if you have integers, a lot of times your answers will always be integers, but I made this one up off the top of my head. So sometimes, if your answers are, for one of them is 1/3, well then obviously for it to add up to be a whole number, you might have to have a 2/3 in somewhere in there, right? For it to add up to make an integer. So I would say yes if they're all integer coefficients and constants to that question.
Okay.
Now some could be able to be reduced sometimes, so the denominators might not all look the same, but obviously in this case a 37 is can't reduce
Because it's prime.
Okay? So you guys kind of follow that?